Hello, everyone. My name is Ilvin Lee from University of Alberta Business School. So I specialize in operations management and data analytics. And so this is a joint work with Mustafa Rezai, my postdoc, and Jen Beverly from the Department of Renewable Resources, all from University of Alberta. So the project is modeling initial attack containment success, answering this question: can historical data inform initial attack dispatching decisions? Okay, so here's a one-page summary of the project background. Many fire management agencies want to understand how resource types and quantities influence their objectives. So here by resource, I'm talking about those suppression resources: helicopters, crews, air tankers, and so on. And for those who want to answer this question, the biggest challenge is the lack of appropriate data. And historically, people have overcome this barrier using simulations or by talking to experts and documenting their knowledge and experience. However, in this project, we decided to take a different approach. So we investigated whether new and modern statistical modeling techniques can extract useful insights from data about initial attack resource use, so IA resource use. So as you can see, from the very beginning, this project was very exploratory. So applying those modern techniques to wildfire data, and these techniques have not been applied to wildfire data so far as we know. Okay, so, well, although it is ambitious and explorative, if it is successful, then that means it builds a foundation for further, more exciting research to inform strategic and operational decisions. Okay, so that was the motivation and background. And looking back, the benefit of this project was threefold. The first one was building a partnership. And we all know that Alberta has the best wildfire data among all jurisdictions in Canada, maybe in the world. So during this project, when I talked to other researchers about the data I used for this project, they were basically all very envious. So Alberta has the best wildfire data, and University of Alberta has operations management and data analytics research capacity. So building a partnership to combine these strengths, to unite strength, was one of the main benefits of this project. And we know that other agencies such as Ontario have realized big success in improving their operational efficiency by working with researchers. But we knew that we could do that too, and also we could do better. And the second benefit was understanding the practice, the operations, and the data. And I gotta tell you, this was my very first wildfire project. So it was a lot of learning. So we spent a lot of time to talk to different people, the WOOs, different managers, and also people from the fire science side, to learn what kind of decisions you make, how you make those decisions, based on what information, and in what environment you make those decisions, and also how your operations work. So such as daily deployment, PPS, and dispatching, and so on. And also we learned a lot about the data. So what each variable means, how they are recorded, who recorded them, and also which part is more reliable than others, and so on. So of course, this was rather a large investment comparing to the scope of the project, but it was an investment for the long-term benefit for in the years ahead. And lastly, of course, the project itself, so insight. So we applied advanced modeling techniques to understand how resources affect objectives. So in the remaining time, I'm gonna just talk about the project itself, the insight. But before doing that, I have to thank all the collaborators in Government of Alberta. So especially those three WUs assigned to this project. So Sean, Kevin, and Tom, they provided really a lot of advice and guidance. And also, I have to thank Lynn for extracting the data and help us understand the data. So with all the help, we got data. So 30 years of historical fires data from the system fires, and also weather readings, daily weather readings from weather stations. We got also a timesheet, so manpower, aircrafts, and equipment, and also fuel grids. Then using this data, we answer the following question. We estimated the probability of initial attack success for different levels of resources. So here, IA success is defined as being held by 10 a.m. next day. Then, about different levels of resources, we focused on the number of firefighter hours, the number of helicopter hours, and the number of air tanker hours. Oh, by the way, because this is focused on initial attack, here all these hours are from the first day the fire was reported. Okay, so this is the problem definition. Yeah, I'm gonna skip all the methods and just go right into the result. So the first thing we did was categorizing all these fires into 5 groups of similar difficulty. So we used, of course, to the suppression difficulty, there are a lot of factors contributing to suppression difficulty. So we throw in all those factors, all those related factors from data, and we use statistical methods to categorize these fires into groups of fires with similar difficulty. And group 1 is the easiest, and group 5 is the most difficult. And here are some numbers about those 5 groups. Yeah, again, group 1 is the easiest. So as we go to the right, it gets more difficult. The top row shows the number of fires. As you can imagine, the number of fires decreases as we go from easy to more difficult. The success rate decreases as well. So in group 1, it is almost always success, so 99.16%. However, yeah, it goes down as you go to the right-hand side, and in group 5, it is much lower, lower than 70%. The assessment size goes up as we go to the right. And also final fire size goes up mostly. There is some exceptions. So when you look at assessment size, group 3 and 4, actually group 4's assessment size is smaller than that of group 3. But when you look at the bottom 2 rows, so the percentage of crown fires, that percentage just goes up as we go to the right. And also the last row is the percentage of fires with HFI class greater than 4, so 5 or 6, and that percentage just goes up. Okay, so from this table now, you see that these groups have different suppression difficulty. And also from this little table, you already see that there are different factors contributing to the suppression difficulty. So assessment size sometimes goes down, but the fire intensity goes up. Okay, so we got these 5 groups. And then for each group, we estimated the impact of the 3 resources on IA success. I'm going to first talk about firefighters and helicopter hours. And one thing we found is that, not surprisingly, groups 1 and 5 are not informative. In other words, varying the resource has little effect. I believe many of you already see the reason. So group 1 fires are going to be a success almost regardless of resources. And group 5 is very highly likely to be a failure, again, mostly regardless of resources. So those fires in the middle, in between 5 groups, 2, 3, and 4, are the most informative, and this is where resource decisions can really alter the outcome, or more likely to alter the outcome. And it is especially so for groups 3 and 4 than 2. Okay, so firefighters and helicopters. We also have air tanker hours. However, interestingly, air tanker hours were not informative in all groups, all 5 groups. In other words, the effect of air tanker hours on IA success was not consistent enough to result in a reliable estimate. So we thought about some possible reasons. We have one here. So air tankers, as you all know, tend to be used under high risk or extreme conditions. So IA success was unlikely from the beginning. And also this result tells us that, so again, I have to emphasize that this study is focused on IA success. But as you know, there can be other outcome measures to evaluate suppression activities, such as time to containment, final size, and so on. And our study shows that IA success may not be a proper measure to evaluate air tanker effectiveness. So we got these estimates for the impact of the resources in each of the 5 groups. Then using these, we can run what-if scenarios. So for example, what if firefighters can spend 60 more hours per fire? So for example, this is 3 hours from 20 persons unit crews. If we do that for group 2 fires, then the IA success probability increases by 1.2% from 97 to 98.2. However, if we do the same for group 4 fires, although group 4 is only 2.9% of all fires, the IA success probability increases by 5%, so much more. So 87.2 to 92.2. Well, so it's 5%. So this is the absolute difference. But when you think about the failure probability, it is actually very significant. So the failure probability goes from 12.8 to 7.8. Okay, we asked the same question for helicopters. So what if helicopters can spend 6 more hours per fire? Then for group 2, the IA success probability increases by 2.3%. On the other hand, for group 4 fires, it increases by 7.3%. So as you see here, using these models we built, we can quantify the impact of additional resources. Of course, we acknowledge that this is a simplification of IA process. We had to make a lot of simplifying assumptions to really enable the statistical analysis. But by doing so, we can provide insight into the return on investment. So what are the benefits of having more resources? Okay, so now I'm gonna wrap up. So we learned that the historical fire data can be used to quantify the benefit of additional resources. And we also learned that, as many people warned us at the beginning, wildfire dispatching decisions are indeed extremely complicated, not just for the decision makers, but also for researchers like us. So there are so many factors to consider and a lot of statistical challenges. However, now we understand the data and the operations a lot better. So this means more opportunities for exciting research. And so based on this experience and all those things we learned so far, I plan to continue doing research on data analytics to derive useful implications for final managers. And here's one example. So we are preparing a proposal to do data analytics for wildfire suppression resource sharing. As you all know, resource sharing is currently coordinated by CIPSI. So analyzing their data, so their resource sharing data and also daily situation reports, including the agency preparedness level, to understand the current practice better and also to evaluate the possibility of more proactive resource sharing strategies. So Jen and I are working on this with other researchers in Ontario, and also we're getting support from CIPSI. And lastly, so this is a picture of myself, Jen's student, and Tom, one of the WUs who helped this project. So Tom graciously invited us to Peace River. So we got to observe their decision-making process, and also we had a helicopter ride to a base. And in fact, the picture in the previous slide is also a picture from that trip. So this is the response center of Peace River. All right, so this is all I have. Thank you very much. And again, I thank Alberta Wildfire, Canada Wildfire, and Alberta Agriculture and Forestry for supporting this research. Thank you.